All right, so I just wanted to touch on a few points before we moved ahead. We had talked about the primary oil extraction. We had said that oil is under pressure underground, and so we had said it's oil is pressurized and it comes to the surface. And as a matter of fact, you have to control it to keep from having those gushers. And we had said, how do you do that? You do that with something called a Christmas tree, which contains valves. And so it closes off and controls the flow of the oil to the surface so that you can capture it, put it in a pipeline or wherever. We then had said that there was this secondary oil extraction, and you could do this by using steam. That would be, so they would introduce steam underground, and you could extract more of the oil that was present there. But the bottom line, the crazy thing is that even though we do all of this stuff, you still are leaving 65 to 70% of the oil underground. Now, a new idea, and it's a pretty good idea. What is the downside to any of these fossil fuel combustion processes? It's what we were talking about in the last chapter. Adding CO2 to the environment, to the cycling carbon cycle, and increasing the temperature of the earth, global warming. So one idea is, instead of using steam, use CO2. Introduce CO2 back underground. Usually I always say in these kind of classes that there are simple answers to environmental problems. The problem is the cost. And so the cost is what prevents that from happening. The other point that I was just mentioning is, I said you have this complex mixture of different size carbon molecules in crude oil. And so when you distill the different components from the crude oil, what you do is you add a certain amount of heat and raise it to a certain point, and the very low molecular weight carbon molecules will come off as a gas, and then you could condense them and capture them as the real lightweight stuff. And then you raise the temperature just a little bit, and you get the next fraction of the oil, which might be gasoline at that point. And then after you've gotten all the gasoline out, you raise the temperature a little bit more, and you get the kerosene. And then after you've gotten all of it, you raise the temperature again. You get the idea, right? So you get the larger and larger fractions of the crude oil. You separate them out. Now, the problem that you have with all of that is there's a much bigger demand for gasoline than there is for lubricating oil. It's like, well, the main reason we want crude oil is to run our cars, not to lubricate the bearings, right? So what they've figured out is there's a way to take a big carbon-containing molecule and break it into smaller pieces, and you get your gasoline. So this is called cracking, not to be confused with fracking with an F. This is with a C, cracking the larger molecules from the crude oil into smaller molecules. And then and the reason for doing this is the terminology we use is that the distillation products do not meet consumer demand. Meaning, we got a whole lot more lubricating oil than we have gasoline, which we want. We want gasoline, and we've got lubricating oil. So what do? You break it into smaller pieces, and now you've got more gas. And that's called cracking, like a crackhead. Crack, C-R-A-C-K-I-N-G. Okay, it's thermal cracking. Okay, is there anything else I need to say about that? Nah, we'll move on.